So far, we have discussed 4 different types of transformations. The first 3 types that we talked about were rigid transformations. Now, what does that mean? Well, a rigid transformation preserves length, which means that it does not change the size or shape. So we talked about translations. Translations were just when we were sliding a figure to a new location. We talked about reflections. So when we flipped a figure over a line of reflection. And we also talked about rotations, where we turned a figure. In all of these, the size and shape remained the same. It's just the location that changed. Recently, we talked about dilations. Dilations are different in that they do change the size or shape. Just remembering this is separate over here. A rigid transformation can also be called an isometry. And like I just said, it's a transformation of the plane that does not change the size or the shape of the pre-image. Remember, the pre-image is the original, and then after the transformation we have the image, which is denoted by the prime demarcations. Reflections, translations, and rotations, as well as combinations of these 3 transformations, are rigid transformations. So anytime you perform a reflection, a translation, a rotation, or a combination. So you could do a reflection and then a translation and then a rotation, or a rotation and then a translation, or a reflection and then a rotation. Any combination of those 3, as long as you only have those 3 types, you're still dealing with a rigid transformation. In a rigid transformation, the pre-image and the image are the same size. Now, just be careful. They may not be facing the same direction. Just because they're the same size does not mean that they're necessarily facing the same direction. Think about a reflection or even a rotation. Those could be facing different directions, but they are going to be the same size. So let's take a look at these examples at the bottom of our page. Each shape marked with a letter matches a shape marked with a number. What's the same and what's different about each pair? So let's take a look. We've got A is going to match with 3. Now let's figure out what's different about them. They are the same size, they are the same shape, they're not in the same location, and they're also not in the same orientation. And by that I mean that we have a spike pointing up here, but we don't have a spike pointing up directly there. So we can tell that these have been rotated. Which is just our vocabulary word for turning it. Okay, B is the same shape as 4, but they're oriented differently. So we know that these have also been rotated. Two and D, in one of them the smaller portion is facing up, and in one of them it's facing down. So we can see that a reflection or a flip has happened here. And then C and 1, they are in the same direction. They're the same size, they're the same shape, they're just not in the same location. So we can see that a translation, aka a slide, has taken place. Now, a non-rigid transformation is a transformation of the plane that changes the size. Of the pre-image. In a non-rigid transformation, the pre-image and the image are the same shape, but not the same size. So we've talked about dilations. So we can see that in this first example with the heart, it was reduced or shrunk. So the size was not preserved there. So we could call that a reduction. We could say that it's a shrink. In the second one, the triangle is in a different orientation, but it's the same size. So we have not dealt with a non-rigid transformation here. In the third one, the sign is in a different position and orientation, but it's not a different size. So it's also not a non-rigid transformation. The lightning bolt did get smaller, so it was also a reduction. So that is non-rigid because the size has changed. The hexagon, the size has changed. So this is an enlargement. And this quadrilateral, the size has not changed. So it is not a non-rigid transformation.